And somebody came up to me and said, I'm not like you. I don't believe I can change the world. And I don't remember what I said at the time, but that kind of stuck with me. Because I don't believe we can not change the world. We do stuff all the time. Whether we take an action or don't, we are affecting the world around us. And this is doubly, triply, factor of 10, 100 true for those of us who write code or make tools for other humans to use. By our choices, we influence how other people change the world, what they're empowered to do, or how they're limited. So, my name is Sarah Allen, and together with Al Gore, I created the modern internet. There were some other people involved, and probably most of the people in this audience. You are responsible for this technology that doesn't work, that doesn't serve the needs of the humans we try to make it work with. And there we go. So we have created this landscape of unintended consequences, software that uses us instead of allowing us to use it, and preventable disasters that somehow we couldn't predict or felt like we couldn't control. So I want to take you back to the early days of the web. 1995, I went to Macromedia to work on a project codenamed Shockwave, which was an ITV project, and that's a whole other story. But I wanted to learn about the internet. I'd never done internet software before. And one of the things that I learned from our awesome web team way off on the 5th floor, and they worked closely with our networking team, was perimeter-based security. So we had a perimeter. I was a software developer. I was safe inside the perimeter. I could write any code I wanted to. And people would be careful to make sure that the bad guys didn't come in. And when we had software to release on the internet, and Shockwave was the first software that Macromedia had ever released on the internet, and that was like a whole new thing, I couldn't just put it on the web. I put it into the DMZ, the demilitarized zone. And then one of the web team people would pick it up and put it, and it was like, I found this picture of the castle, right? These are the Mott and Bailey castles. And there's this wall, like inside the wall, you can go into whatever house you wanted, right? And and we were safe inside the wall because we all have computers and we're all employees and stuff, and there's security guards, the exits and entrances. And then, like there's this extra secure place, right, that touches the internet. So things were fortified in this way. And so we took Macromedia Director, the player that ran off CD-ROMs, and we made it into first a helper app and then a Netscape plugin. And I worked with Harry Chesley, who had been at SRI when TCP/IP was invented, and he really understood this internet software stuff. And he went through Lingo, the scripting language, and he pulled out all these incredibly useful commands that he said were unsafe. And I was like, but wouldn't it be handy to be able to open files? And he told me, yeah, I'm sure most of you know why that's a bad idea. Yeah, but then somebody's going to create this entertainment or interesting movie and then be able to open files on your computer. And I was like, oh, good point. That's a good idea to prevent. So I started to really learn about internet security. And then we released Shockwave. It was a native code plugin. And then, people made these neat things for kids to learn how to build stuff with Legos. And, it was really good. We turned off those unsafe features because kids are running them on the family computer. And then this Flash thing happened. Of course, at the time when it started, it was called Future Splash Animator. And I recently reconnected with Jonathan Gay, who wrote the original Flash player, and he said that they had the first implementation was in Java because it was before the plugin API came out. And Java, as you know, has a sandbox, and some of you might not remember that it was at first a client technology, but it was so slow that you couldn't do something like Flash or Shockwave in it. It just was not practical. The files were big, and the performance was slow, and we couldn't do anything that humans would want to use of the scale that we wanted to do in terms of the performance and the fidelity with Shockwave and Flash. So I joined the Flash team, fast forward 5 years to the 2000s. And by then, Flash had adopted many of the features of Shockwave and had ActionScript. And I joined when we added two-way audio video to the Flash player and the server. And I had this vision that I was inspired by Doug Engelbert. Who knows this? If you don't know this, Google tonight or tomorrow, this weekend, the mother of all demos. So everything that we created, with two-way audio video and Flash, Doug had done, in 1968, with analog video and interactivity, and he is most well known for inventing the mouse, but he also invented cut, copy, and paste. Holy cow, he believed that computers needed to augment human intellect. And I knew this stuff was mostly used for entertainment and fun, but I thought, we're going to just empower the next generation. And so then, this happened. And it was really cool that I could watch every single episode of Lost, even if I wasn't, available on the day it was shown. But this wasn't exactly the consequence that I had expected from working on this technology. And it was really, I think, this broadcast video adoption and making it easy for people to consume entertainment whenever they wanted to, and films and network TV that caused this Flash Player 6 to be adopted by, it was the fastest version of Flash that was adopted, and in a year and a half, 90% of people on the internet had this new version of Flash. And then I looked back, and between 2001 and 2019, there were 1,172 what they call common vulnerabilities and exposures, CVE reports of ways that people could exploit errors or vulnerabilities in the Flash player. And that sounds really horrible. I mean, those were, some of those were fixed. They didn't all happen at once. But when you have a popular piece of technology, it's, you have a big target painted on yourself. And it turns out that Flash had fewer vulnerabilities than the browsers in the day. The reason those vulnerabilities were so scary is because Flash was installed in all the browsers, so that no matter what browser you had, you also had Flash. And so that created this homogeneity in the internet, which on the web, which meant that there was this one thing that you could attack on a particular platform, which made it particularly scary, which has led to the browser folks being, I think wisely, saying, okay, let's not have native code plugins to the browser anymore. Of course, now browsers do a lot more, so that's not as necessary. So I did a little analysis of these. One thing I forgot to say. The number of these is not significant. This doesn't actually mean Flash Player necessarily had fewer vulnerabilities. And this, I don't think, means that Firefox had the most. What the number indicates is probably the rigor with which the team reported these vulnerabilities and that the community documented them. And it may or may not be related to the actual number of vulnerabilities. So when you see these numbers, you always want to look at them with that lens of, what are those vulnerabilities? Should there be more? Should there be less? You don't want there to be 0, because then nobody's looking. And you don't want there to be, I think the key thing to look at is, how quickly are they closed? How does the company respond to the fact that a vulnerability is found? And these are complex things. People like simpler things, but sorry. So I looked through these vulnerabilities, and the vast majority of them are memory safety. Who here has written C code or C++ code or something unsafe? Unsafe code. OK, most of you. So those of you who've had experience know how easy it is to write code inadvertently that isn't safe, right? So you just have a coding error in these kinds of languages like C and C++, where suddenly your computer crashes. And then you get these issues of memory safety can cause, and then there's other ways where you can cause other code to execute. But I think it's worth noting that there's a whole other set of errors. I'm a big fan of Rust. Like I'm learning Rust. It's really cool, and talk about like fearless coding because it's so safe. But I'll get into it a little bit. Just because this huge class of errors is taken care of doesn't mean it's OK. You still have to think about things. So I want to take you through a little bit of these. There's a whole bunch of different classes of errors. And many of them are typically coding errors, right? Classic coding errors, like use after free. Yeah, you should have known better, right? But like memory corruption and like heap overflows, a lot of these can be just input, right? Somebody sends you unexpected input, and then you end up accidentally crashing the machine or executing random memory, except that somebody clever can make it not so random. So the memory safety CVEs that I went through, I highlighted a couple of descriptions, right? So it allowing remote attackers to execute arbitrary code from a well-crafted Swift file. Like I learned how to talk about malicious Swift files, like malicious Shockwave movies could do these evil things. And it was hard at first to think about that the user input you expect could be subverted to cause your program to do something unintended and, in fact, hurt the user you're trying to empower. And so this is the main point. You might not have files that you're loading off the internet, but if your program does anything, it probably interacts with something that is not in your control. And those inputs can cause your program to do unexpected things, even if you're using a type-safe language and you're parsing things correctly. The content can actually trick your program into doing different things. So, but probably the number one scary thing is just letting people run arbitrary code. So this is an example of a bug. And those of you who write C code know that this says I have a long integer, a, and I'm going to set a to the value b, and I'm casting it. So in C, you can have different types that you can be like, oh, no, I'm just going to assign it to this other type. And there's a lot of bugs that can happen because it'll chop off some value, or it's this doesn't actually tell you whether it's signed or unsigned. There can be logic errors in there. But I wouldn't have expected this to crash, and neither did I ran into Brad Edelman, and I asked him for an example of one of these tough bugs. And it turns out that nobody on the team actually realized, or nobody on our little team that was modifying the Flash player, realized that casting a variable, you could override what happens there and execute your own code. And so some other part of the Flash team had actually written some code that executes when you cast a variable. So when you think about things you don't know, it's not just the environment your code runs in, right? And the inputs it's getting, the files it's absorbing. It can also be the compiler, the libraries you're using, other members of your team that do things that change your primitives. And sometimes we have tools that protect ourselves, but misunderstandings are, I've seen, a bigger source of security vulnerabilities than pretty much anything else. So unexpected context. There are these other examples that I pulled out of the Flash CVEs, which I thought were entertaining and interesting, but maybe you have situations, or the rest of this talk can help you think about where your code might be used in a context that you don't expect. So we were focused on web technology. So it turns out that at the time, maybe probably still today, in IE, the extension mechanism was ActiveX controls. And so that's how you wrote something to play on the web. Turns out you can also run ActiveX controls in Excel. We never really thought that anybody would run Flash in Excel. I wasn't even aware that that was possible with ActiveX controls in any case. And it turns out that it's really useful because you can put multimedia content, instructional content, embedded into your Excel document. So now suddenly somebody gets an Excel document on a disk or off the internet, and they don't think that an Excel document could actually do something malicious. But if it has an ActiveX control embedded in it, and that ActiveX control has a vulnerability, then all of a sudden that's an attack vector. So these things, it took me a really long time to understand how these multiple vulnerabilities go together. And one thing that you just think is so unlikely, one is you get popular. It's likely that somebody's vulnerable to that, right? And then they can be combined together to be useful. So, so then getting back to the parsing validation, so there's a whole bunch of different keywords that I kind of pulled out and I'm classifying as parsing or validation errors. And I have gotten to the point because of this experience where, like, if I have to do some like URL parsing or XML parsing, I'm like, I'm going to go find a library that's widely used because parsing is scary. Not that I don't feel like I could write a parser, but sometimes I've run into younger colleagues who are like, hey, it's just string parsing. I can do that. And we don't even need the full feature set of URLs. So why would I use this library that I have to learn? It's easier to just, type some code. It is always easier to just type some code. Who has written code that has no bugs? Somebody over there. OK. Somebody who hasn't written code. So people, they don't, when people think about hard problems in computer science, like parsing is, has not historically been one that I've read about when people talk about hard problems. But I think it's one of those tricky problems, right, that you just want to get right. So I was preparing for this talk like this summer and happened to come across on Twitter a bunch of URL parsing vulnerabilities. And this is not to call out these people because I'm sure it would seem like a good idea at the time. But Envoy proxy, it's written in C or C++ in native code, and they had some vulnerability that they found and fixed. But if you're using and I was using Rust, so I was learning Rust, and there's 3 URL parsing libraries, and I'm like, is this necessary? But it's a young language. We'll get there. And and then there was one in I think this was in Go, where it was unfortunate that this was discovered late because they actually had to change the API to resolve the security problem. So this is another thing to think about. You might think, OK, well, this is the first release, or it's a bit, I'm not going to worry that much about security. We'll get to it. Because there's always time to fix that, and we run software on the internet these days, so you can just patch it like that. It's awesome. I'm not saying you should do that, but I have empathy for, features versus security. There's an endless row of things you should do, right, in our lives as programmers. But this is the point that I want, if you don't know this already, the API that you design, your docs, are not your API. Inadvertently, somebody will just use what works, and then you're stuck with it. So somebody's writing correct code that is doing a good thing for their users and your users, but they inadvertently use your API inappropriately. And then some bad person does that, and you discover it. Now you have to break the people who are doing good things to save your users from the people who are doing bad things. So when you're like, if you're going to pay close attention to anything, right, it's that API surface, not just in terms of, like all of the safety things, but does it have like the surface you would need to make it safe? Which is like, if you're going to prioritize, that surface is way more important than the implementation, because the implementation is easier to change than the API surface. So I went through like the dark ages. Web is for content. You've got physical networks. You've got like an air gap. Like we've got machines in a room. They've got a lock. We've got an isolated network from the scary network that's attached to the internet. And HTTPS was actually expensive, right? Doing memory-safe stuff, like with Java, was actually computationally expensive in the 90s. So we didn't have all the tools that we had today. And I'm going to take you through like a little sequence of, how hospital, like just a hospital as an example, right? This is true for any business, but particularly in highly regulated ones where things are scary. So, historically, we keep everything on paper. We have machines in the basement. They're mechanical. They're totally unrelated to the things on paper. Why would they be? The interface to this is the person at the front desk and the friendly doctor who looks up your file. They walk into the locked room. They look up your file. They tell you stuff. So, and then, we have more paper as an interface to the paper and the physical buildings. And everything is like, there's danger, but we can, we kind of know how to make that safe. So, and then we introduced machines, and this is okay. This is like the turn of the century. The EKG machine was created. What's his name? William Einthoven got a Nobel Prize for it in 1924. I didn't know these things were like in hospitals in the early part of the 1900s. So, but all of these things are decoupled, and you have security machines, right? But those are not complete, they're analog, they're completely separate. All of these things are completely separate systems, right? And then, then stuff happens, right? Like, so each of these different systems evolves separately. They each become digital. They each take advantage of modern networking. There's easy components and easy software to do with the internet protocol. These can all be separate systems with air-gapped networks and perimeter-based security, even if they're all using the internet. Except you start to connect them to the actual internet, and then suddenly they're all connected to each other. And sometimes they're connected to each other on the inside, too, just for convenience, or it's going to be more robust if they all go over the same channels. And, hey, we've got, firewalls made out of software, and we know that always works. So, so we have manage your healthcare button. This is like helping people. They can access their healthcare records online from a web browser. This is electronic health records. If we connect all the things, they'll be more usable. That's really good. And then if we get like all of the physical things connected, the heating and the patient sensors, and we can then know that we can make things more efficient. That's good for the, saving energy. It's all great, and this is a huge growth market, right? Some of you in this room are probably like, if you're not working on this stuff now, like, this is in our futures, right? This is exciting growth, yay. Except it's also a little scary, right? Now on the internet, we not only have PII, we have like our real information. So we're not just like playing games and watching movies. Our financial transactions, our real world health records, our real world physical stuff, right? Like the temperature in the hospital where we're getting an operation, the power grid, these are all connected to the internet. There's bot armies that people can control, so you no longer have to stand up individual machines, right? You don't even have to pay for virtual machines. You can just like run an algorithm and take over a host of cameras. There's new types of attacks that have always been there, but now they're much more fruitful because you can get real money and do real damage if you attack things. And things are in the cloud now, right? Which means that who's doing cloud stuff? Ooh, about maybe almost half the audience. So cloud is awesome. And everything's controlled by software, yay, and we know that always works. But we do have ubiquitous crypto, and machines are fast. It's baked in. It actually is practical. So now, instead of this perimeter-based security, we need like each of our services, each of our little pieces of software that runs in the cloud, or sometimes even on-prem, right, to be its own little castle. And we have crypto to protect it. We need to pay attention to the ins and outs of our software, even if it's running within our so-called perimeter. And you know, like modern software systems look more like a medieval castle, because like you've got all these isolated services that should have protections and should have careful egress and ingress about who talks to them, even if they're within the outer wall, because the outer wall might be breached. And you might be saying, okay, here she is, doom and gloom. The cyber apocalypse is nigh. I feel these days like I should be wearing like a tinfoil hat when I talk about these things, but like this stuff's real. So the main problem is like a little oversimplified here, but humans make mistakes. It's not just the bad people, right? Bad things can happen to your users because of mistakes. And then those mistakes are compounded because then there are bad people in the world. So like, here's a bunch of headlines about the kinds of things that happen today. So the world is changing, right? We have like, you know, scary stuff going on, but the fundamentals of security are basically the same. So these vulnerabilities create opportunity, right? So we all have to be on the lookout for these. And I think it really helps to have a practical example. Even though I've been doing security stuff for a long time, I used to pretend I didn't do it and I never put it on my resume because I like to make stuff. I'm an application developer at heart, and I don't like to think about the bad guys. I like that to be somebody else's job, but I would always think about it because you can't think about it at the end and get it right. So, but I found this great use case. So we're in the UK, so maybe who heard about this Target attack a few years ago? It's like a US company where all the credit, like if you used Target in the last several months, your credit card was stolen. And this was like a pretty big deal that cost Target a lot of money, like even more than that in terms of like actual like costs. This was just, I think, the settlement cost. And I found this great article that went through what it took. And the article goes through 11 steps, but these are actually just 8 vulnerabilities. So somebody spent time over months, probably, to find and exploit 8 different vulnerabilities that all had to work together to be able to get 40 million credit cards. So the first, this was all the arguable root cause, right? Which is not really the root cause, but the entry point was the HVAC system. So this is, people were like, how could my, you know, the HVAC system is the, like, you know, the thing that controls the heating and air conditioning of a building. How is it that that can be an attack vector? Well, they'd upgraded it, now had remote access, and these malicious actors basically figured out who had access and installed some malware on one of the human's machines at home, and they type in their password, and their password is gone, right? So that's hard to protect from, right? You have a lot of employees with remote access, and so that was the first thing. Then they're in, right? And then they find a web application that's vulnerable, that people are using internally. And so they take advantage of that vulnerability to get code running on a server inside the firewall. But you know, a system like this has many firewalls. The HVAC system's not really connected to the other things, right? So they, you know, like you basically, you know, get a foothold somewhere, and then you look what you have access to and crawl through the network that way. One of the things they managed to find was a administrative machine that then they caught a token from a domain admin coming in. They were able to use that token within a short window and make themselves a domain admin. Whew, now they've got powers. But they still don't know where the credit cards are. They keep going around from machine to machine, and they find a SQL Server. It's got 70 million people records in it, but it doesn't have the credit card information. Yay, PCI controls. It's a thing we have in the US. So maybe they sold that on the black market, who knows. But they keep looking, and then they find the actual point of sale machines, those like the little machines you put your credit card in that are accessible on the internet, of course. And that was the first time that they had to write custom malware. All the other stuff just off the shelf, tools we might use all the time or tools that are just open source on the internet. And they actually scanned the memory of this point of sale machine to look for things that looked like credit cards, stored them on the local disk. Of course, we're not done. We have to get them out, right? So then now they have those domain credentials. They create a network share. They put the files over there, and then they exfiltrate the data and manage to get it out. So these are tons of vulnerabilities, right, that are being taken advantage of. And this is why one little bug is something that you should probably pay attention to. And this was the kind of thing that it took me a while when I was first writing internet software to really get my brain around that, like, yeah, people do this. And it may have been less common in the 90s, but today, whatever you're doing, wherever your software runs, it might be just a hop or 2 or 8 away from something that's actually connected to the real world or connected to real money or some artifact that will have an effect on the real world. So how are we on time? So the main thing is you have to assume you're going to get breached, right? You make your medieval castle because you know the outer wall is going to come down at some point, right? And and I think the other thing is you want security experts on your team that are like paying attention to what's going on your network, because that targeted hack must have taken months, and somebody might have seen it happening. One last story, which is there was a plot to steal cryptocurrency. This is a completely different class of attack, which is a supply chain attack, which is much, much more common today because we have continuous integration and continuous deployment, and we can just if we automatically pull in our dependencies when they have an upgrade, then we're running new code that we've never looked at. So don't do that. Review the code that you take in. But basically, this particular thing was caught by the NPM security team, and somebody had posed as a legitimate person and made months of legitimate improvements to a particular open source library, and then volunteered to help out the maintainer, and then the maintainer went on vacation, and then they put in malicious code that got integrated into this system. And then that engineer is running code inside basically a bank. Luckily, they caught it, and they fixed the problem. So in summary, all these things are new today. You know all this, right? What I think we all have to remember to think about is, what is the code that's out there already that your invention is changing the rules? That maybe you are inadvertently creating some vulnerability because you're making the environment for some other code different. And and that doesn't, I'm not saying what to do, but to think about it and to think about the implications for that. So I want to have some positive takeaways and not just give you scary stories. The main thing is that security isn't binary. It's not, oh, yay, we've made it secure, right? It's a process. So secure is a verb. It's not an adjective. Talk about what you're doing to secure your system, not whether it's secure. What are the risks? What are the threats? What are the potential unintended consequences? Assume anything that can happen will. We've got the economies of scale. Don't assume you won't be successful. That doesn't fly with the business people. Tell the business, if you're having trouble convincing people, the best shot is to not try to convince anybody, just do it. It's your job. But if you find yourself having to convince somebody, paint the picture. If success, then. If you can't get time before the 1.0 release, do an API audit and schedule it right after. We need to defend doing the right thing here, because we're the only ones who understand this stuff. I'm not doing security because I like it. I'm doing security because I don't think we understand how to make secure software or safe software or good software in this day and age. And I don't want to make stuff that's going to ruin the world. So, or not again, sorry. So just don't make a new parser or new crypto unless you really, really need to. Invent new things, right? The world needs lots of awesome software, so focus on that and take the time to learn the stuff that's already out there. There's a lot of great tools and new tools being made every day, so just carve out some time every couple of weeks, every month, whenever, whatever's the right pacing, to try out some of these tools and just stick them in your workflow, and then you don't have to think about it because one thing is taken care of, and you can move on. I think the memory-safe languages, type-safe languages feature, like there's a lot of, I think love for that in this conference. And now we have an opportunity to use some of these tools that people have been working on for decades, where there is good reason to spend a little more time making the software work well out of the gate. Oh, and if you're not using a memory-safe language, almost all the unsafe languages have features or libraries that give you that stuff. So contribute to your open source dependencies. They are your code. So one thing, I'm a member of this cloud security group that's part of the Cloud Native Computing Foundation. And like I said, I'm an application developer. I've led a lot of teams. I live by the checklist, right? You get a really serious bug, it's on the checklist for next time, right? I love my software development checklists. And Justin Kapos, who's a member of this group and a professor at NYU, was like, no, we shouldn't have a checklist for people. And I was like, what? I really want a checklist, please. And what he pointed out, which I think was very astute, and echoed by a number of the security experts in the group, was that you have to be really careful when if you give somebody a checklist, because the most important thing on your checklist is that you think. You're making new software for a reason. There's something new about it that isn't on the checklist. So if you have these security procedures, some of you will. I worked for the government. Believe me, as soon as he said it, I'd realize, oh yeah, the 3 months of going through the 3,000-point checklist to put a website up in the US government, during that time, you're not updating your dependencies. And there's a security flaw, so by definition, when I was working for the US government, my shorthand is, in order to make things more safe, we make them less safe. Because sometimes the process itself causes the problems which cause things to be unsafe. So that said, here's a couple great checklists. If you're new to this, I really like these resources, the CII best practices. Don't go through them like a checklist. Go through them like, I'm going to go through and do the things that are most important to me, and then set aside time to think. So I'm Ultrasaurus on all the things. If you're interested in this stuff, I would love to hear from anybody. I think it's one of the big problems facing our world today. Thank you.
Thank you, Sarah. We have time for one question. Who is the brave one? Want to share some of your Flash stories or? Anyone? Everybody's hungry, I think. That might be the reason. So thank you, Sarah, and see you after the break.